Hi, so this is the 5-2 c4u. Hopefully I'll get through this recording without coughing my lungs out. To begin with, we want to write equations in standard form from the given roots. So we have x equals 6, x equals negative 9. The roots give us the factor, so if I subtract 6 from both sides, I have x minus 6 equals 0. And similarly, x plus 9 equals 0. These two factors foiled together will give me x squared, and negative 6x plus 9x is positive 3x, and negative 6 times 9 is negative 54. All of this equals 0, but we know f of x equals 0 when you plug in x-intercepts, so this really is our function, f of x, or at least one function that represents an equation that goes through these zeros. If I have x equals 0, and x equals 7, then if x equals 0, the factor that equals 0 is x, and no more. If x equals 7, then the factor is x minus 7. And these two things foiled together, well, multiplied, is x squared minus 7x, and this is our f of x. And we have x equals 2. If you are given a single root, a single solution, this only happens when you have one x-intercept, or the vertex of your parabola is sitting on the x-axis. In this case, x equals 2. If you have a repeated root, that's not unusual. We just have the factor x minus 2 twice. Foil this together, and we get x squared minus 2x is minus 4x, and negative 2 times negative 2 is positive 4. When you have fractional roots, you have a choice. You can either have the factor x plus 1/2 and then try foiling it together, or we can multiply 2 on both sides to get rid of the fraction altogether. And we have 2x and add 1 to the other side, plus 1 is a factor. And similarly, x equals 3/4, multiply 4 to both sides, and we have 4x, subtract 3, minus 3 is a factor. Foil these together, and we get 2x times 4x is 8x squared. 1 times 4x is 4x minus 6x. 4x minus 6x is negative 2x, and 1 times negative 3 is negative 3. All right, solve each equation by factoring. The whole point of factoring is setting it equal to 0. That way we can utilize the zero product property. Or in other words, if x squared equals 64, subtract 64 from both sides so that we're set equal to 0. And now we can utilize the zero product property when we factor this and get x plus 8, x minus 8, the difference of two squares. And when I have two things equal to 0 multiplied, then x plus 8 equals 0, or x minus 8 equals 0. Therefore, x equals negative 8, and x equals positive 8. Or plus or minus 8. If you recognize that I could square root property this immediately, that is a valid way of solving this, and much shorter. If you square root x squared and 64, we get x equals plus or minus the square root of 64, or 8. And that is a perfectly valid way to solve this. If we have the zero product property with x squared minus 9x, we still go through the steps of factoring. If it's set equal to 0 and we're able to factor it, in this case, GCF, x, pull out an x, we have x minus 9 left over. Therefore, x equals 0, and then we're done. Or x minus 9 equals 0, and then x equals 9. Finally, the hardest GCF factoring problem that we could do is if there is no GCF, in this case there is none, and we are stuck with a not equal to 1, such as 3, we are forced to either factor by grouping, or at least utilize the shortcuts that I'm going to use today, which is, we still find a times c, which is 3 times negative 10 or negative 30, and they add to b, negative 13. Now the two numbers right off the top of my head I would think of are probably 10 and 3, because 10 and 3 have a lot to do with 13. But one of these numbers needs to be negative when multiplied, and negative 10 plus 3 doesn't work, and 10 minus 3 also doesn't work. So I would skip ahead. Clearly 5 times 6 doesn't work, but 15 and 2 multiply to 30, and they also have something to do with 13 when one of them is negative. So I say negative 15 and positive 2. Now, instead of factor by grouping and breaking in negative 13x to negative 15x and 2x, which you can, if you're comfortable with that, continue to use it, I'm going to write parentheses, my negative 15 and my 2, and the way I'm able to do that is I write my a value, 3x and 3x, twice, and I wrote one too many times x's. So, to get rid of or allow myself to multiply by one too many x's, I'm going to divide at least one of these factors by a sum total of 3. So I have both multiplied by 3 and divided by 3. Therefore, I did not actually add in any extra information that was unnecessary. So I have x minus 5 and 3x plus 2. So this works because I have x times 3x is our 3x squared, negative 15x plus 2x, there's our negative 13x, and negative 5 times positive 2 is our negative 10. So in the end, this does work. If you prefer factor by grouping, that will also lead to this answer as well.